Okay, so we started with the research design, and during the research design, we have to mind about uncertainty in your dependent parameters, because the dependent parameter gives the confidence. If your uncertainty is very high, no one will believe your outcomes of research. So we have to limit the uncertainty in the dependent parameter, and for that, we do the uncertainty analysis. Okay. So I told that we have to use this uncertainty analysis for designing your experiment. Okay. So in what way it can help you? So it can help you to reduce the uncertainty to the acceptable level, to select the measurement method, and selection of instrument. Okay. So now we'll see one by one the examples with the calculation. In calculation, we'll see. Now, this is examples I've taken from the book that I mentioned. Okay. And this is experimental methods by Holman. Okay. So I've taken the same example. I've not made any change in that. Okay. A resistor has a nominal stated value. So here, this example gives a feeling like how uncertainty analysis can be used for selecting the measurement method. Like here, in electrical circuit, power we can calculate as E square by R. E is potential difference and I is the current, R is the resistance. Like there are two ways to calculate the power. We can calculate V into I, or we can calculate E square divided by R. So in this example, you need to find which method of power measurement is having less uncertainty, less error. That method we can use. Okay. So voltage E is impressed on the resistor. The power dissipated can be calculated in the two different ways, like power is equals to E square by R, or power is equals to E into I. In case one, only the voltage measurement is made, because we know that value of the R already known. Only what will measure voltage. Okay. E is the potential difference. Okay. So E. While in second method, we measure both current and voltage. So for us, it is good because in first method, we want to only measure the E. The second method, we have to measure E as well as current I. Okay. So here there are measurement of two variables. Here measurement of only one variable. Okay. So we have to see which method is accurate. Now error in measurement of voltage is given. For voltage, it is 1%, and for current it is also 1%. The nominal value is 100, and for current it is the 10 ampere. Okay. Okay. Now we have to use uncertainty calculations and say which measurement method is better. Okay. I'll do the calculations now. This is a circuit. Okay. Here we are measuring current. So please understand, even if you are not understanding the electrical if you are not aware about the electrical engineering, no problem. Only the thing is we have to appreciate is uncertainty calculation. Like current we measure in the series and voltage we measure in parallel. Okay. So don't worry about this. Only thing is that you have to do the calculations. Okay. Now, in the first method, what is first method? Power is equals to, first method is what? Power is equals to, I'll just make it little big. Power is equals to E square by R. Now, we have to use the formula. Now it is what? Multiplication. Okay. It is a multiplication. Multiplication of what? E square into 1 by R. So what do we have to take? Partial differentiation. Now we take partial differentiation of P with respect to E. What is meant by partial differentiation? We will consider only in the denominator, whatever we write in denominator, that only as a variable and other variable as what? Constant. What do you consider? The variable in denominator as variable and remaining thing as a constant. So here 1 by R will remain constant. Only we have to take the derivative of E square. What is derivative of E square? It is a twice E. Okay. Twice E. And 1 by R will be same as it is. So it is a twice E by R. Okay. Then you take the derivative with respect to R. So we do derivative with respect to R. It is a R power is minus 1 by 2. It is 1 minus 1 by 2. So what you do? You add and you calculate. So it becomes E square divided by R square. Okay. So it is 1 by R means what? R raised to minus 1. So we subtract 1. So it becomes R raised to minus 2. So it becomes del P by del R equals to E square by R square. So now you have to use uncertainty formula. So omega P will be omega in the, that is uncertainty power is equals to square root of the del P by del E square. That will be 2E by R square into omega E square. Okay. Plus del P by del R square, that is E square divided by R square into omega R square. Okay. So here I think it is a negative sign. Okay. Because R sign is minus. Okay. R sign is minus. Okay. So it is 1 by R. 1 divided by R, that is the power is minus 1. So that's why minus sign is there. Okay. So you take, calculate this, you put the values, you'll get omega in uncertainty power as 22.3 watt. Okay. Are you getting this? I will again repeat the formula. Okay. In this way, you have to calculate. Okay. We're calculating uncertainty in the percentage. So we got uncertainty in the first method as 22 watts. So we can also calculate in the percentage. Now we'll go to next case. Again, in the next case, E or power is equals to E into I, V into I. Okay, sir. So here, instead of P, we are using the E. So E into I. Okay. So you take derivative del p by del I. So only the E will be del p by del E. Only E is variable, I is constant. So it becomes if you take derivative of E, so it will become 1 into I, it will be I. Now you take derivative of P with respect to I, so I becomes variable, derivative of I will become 1, E is constant, so you'll get E. So you just put the value now. Uncertainty in power is equals to square root of del P by del E square, that is I square, into uncertainty in the E square plus del P by del I square, that is the E square, into omega R square. Okay, so put the uncertainty there. Okay, so you'll get the value of 14.14%. So you see that first method, even though we are measuring only one variable, gives more error as compared to second method, where we are measuring two variables. Okay. So please understand, even though first method was easy because only measuring the one variable, and second method where we are using the measuring the two variable, but we selected second method because it is more accurate, having the less uncertainty. Okay. So this way we can select measurement method using the uncertainty analysis. Now next is selection of instrument. So like power in previous circuit to be used by voltmeter with considering resistance of voltmeter Rm. Okay. So you can do the calculations. Okay. So power, we can calculate now. Power is E square by R. So if you put either E square by R or power is E into I, nominal value of E is 100 and I is 10. Now you put the values. Okay, you put the values and then calculate. Okay. So you get this much uncertainty in the power. Okay. So I will share that again, complete calculations. Now we'll move to the next topic, that is the calibration of measuring instrument. Now, whenever we measure the thing, please understand each instrument will have its own measurement error. Error may be less, error may be more. But in the research, we should be very clear that how much is the error in measurement of particular parameter, particular variable. For that, we need the calibration of our measurement instrument. Okay. In calibration, what we do, we compare the two measurements, that is the known magnitude, with one device and another measurement with the second device. Okay. So why we do calibration is to create confidence in our mind and to evaluate the uncertainty. Okay. So whatever we measure, how much is the error, uncertainty, that we must be sure. Okay, what is the error in the measurement? Because we have to mention in our research that what is the uncertainty in the your measurement. If you write my uncertainty is 10%, no one will accept your paper because uncertainty is very high. Okay. So we are not to tell lie. We have to tell whatever is fact. In the research, please understand, don't be biased. We have to present the fact, okay, whatever it is, okay. So when we go for calibration, first thing is that we have to try to have calibration with the primary standard, and if not possible, then go for the secondary standard, okay. Now we'll see what is the primary standard for measurement of volume, okay. Measurement of flow rate, what is the primary standard? So in primary standard, what we do, we measure the volume, we measure the time. So V by T becomes flow rate meter cube per second. Okay. Then comes data collection. So please understand, research is a long-term process. Your PhD, it is 3 years, 4 years. Okay. So we have to maintain data properly in proper book, and when we write the data, we have to clearly give the heading, write the date, time, clearly write about what the data is. So when we generate data by ourselves, it is called as primary data. When the data is obtained, when the data is collected from other, it is called a secondary data. So primary data is always good because we know where it is wrong, what was the condition when we took the particular reading, what can be wrong, okay. But in secondary data, when we take the data from others, we don't have any idea about this, okay. Okay. So I will say that primary data is more reliable. So take as much as data possible so that we need not to repeat the experiment for unplanned thing. Okay. So here I will give one example in my research. Okay. So you take as much as possible, like in my research particular thing, we are having the it was in the 6 outlet and 1 inlet. Okay, so even if I measure this 6 outlet and do the summation, it will be the inlet. Okay, so what I did, even though logically correct, if I measure this 6 outlet and some that will be inlet, so still I measure this inlet. Okay, we call it as a measure some extra data for validation. Measure some extra data for validation. Take as much as reading possible. Like I was not taking one single reading for each. We can say each point I was taking 3 readings. Okay, so if something goes wrong, we can accept the one of the reading. Take some extra reading so that we can cross check or something goes wrong. Suppose out of this 6 measurement instrument, if one is not working, still I can find from this, if I measure at the inlet extra, if something goes wrong with one instrument, still I can find out the flow rate here. Okay. So we have to measure something extra so that if anything goes wrong, we can take care of that. Okay. So when we take the readings, we write down in the notebook as well as properly store in Excel. If this data is too big, you can store in the Excel. We keep the backup in the PC as well as some briefcase, maybe storage in the Google. Okay. Gmail you can store. Okay. So long term, you have to preserve the data because sometimes you may lose the data if your PC get corrupted or anything. Now, once we have obtained the data, then we have to go for analysis. In the analysis, what we do is we plot graphs like plot the different graphs, PV or maybe TS like this. There can be different graphs, okay? So graph gives nature a relation between the two parameters, whether it is a linear, exponential, like this, okay? Similarly, if it is CFD analysis, we can plot contours, vectors, vector plots, and after plotting comes to find the relation between the variables, between the dependent variable and independent variable. Like if I see give the relation, like Reynolds number, Prandtl number. So what is the relation between them? Okay, we don't know the parameters like A, B, and C. Okay, so in the research, we have to find this parameter A, B, and C. For that, what we need is we need to take the help of Excel. That session I will take use of Excel, okay, to find the relationship. So what we have to do is we have to use the Excel, and when we generate the relationship, maybe some simple relationship I will tell you. Then you plot the R square value, coefficient of determination. For better fit of curve, the R square should be ideally 1. R square should be ideally what? 1. And as well as we have to check visually whether suppose this is my data. This is my data. This is a curve obtained. Okay. So I have to also visually see whether the pattern of data and pattern of curve is similar. Suppose the pattern of data is something like this and curve is going like this. So usually I have to see whether pattern of data and curve is similar. Like here it is similar, here it is not similar. Even though my value is R square is high, but the pattern is not matching, then not select that relation. Okay. So we can use Microsoft Excel to find the relationship between the dependent and independent parameter. The session I will take. Now, next comes, now we have collected data, we have analyzed the data. Now comes interpreting the results. Like, I will give the example, like suppose there is some accident and doctor tells you to have the X-ray. So X-ray is like a result. X-ray is like the result. So doctor can interpret that. Similarly, you should able to interpret the result and you should able to conclude. Okay. So researcher must able to explain good or bad performance of component based on the theory learned by him or her. Okay. So you should able to explain why the performance is good for particular parameter, why it is bad. Like, for example, like a hydraulic component may have bad performance. Okay. Then, based on the contour graph, the person must able to explain why a particular parameter, why particular component is having poor performance. So you should able to explain that is maybe because of flow separation, disturbance, and he should improve that parameter or improve the performance. So he must be able to interpret the result. So what we need for interpreting a particular behavior is a good background of theory. Please understand. What is needed to interpret is good background of theory and use of tool. Two things are needed: use of tool and good background of theory. Okay, to interpret the result. Okay. So interpretation will help us. It will highlight the points of poor performance. And next phase, we can improve this point of, we can say, poor performance. Okay. Similarly, we can use in the convective transfer. Okay. So heat carried by fluid should be equal to heat supplied by the heater minus heat loss. So when we go for experiments, like I given here one example of heat transfer setup, I will just draw. This is a duct. What happens in the outside of the duct? We put some insulation. Please understand, insulation will reduce your heat transfer. It will not make it the heat loss zero. Please understand. So in the experiment, we need to also calibrate this setup for heat loss, because we know that heat carried by the gas, will be heat supplied by the heater here, which we read by V into I minus heat loss. Okay.
Sir, I have a question.
Yes, yes. Yes,
Sir,
please.
sir, can you also please take some examples from humanities, arts, or management also?
Yeah, for that,
Because
what we have to do
we
is,
fail
yeah.
to understand these things, sir.
Yeah. So please understand, mostly all these streams like the science, engineering, they have some common base. Okay. But if you send some research paper to me, I can also make few example from your area. Okay. So I request all the participant to send few papers to me directly to my WhatsApp, and also mention your area. Okay. So that I can also create some example from your area. Okay.
Okay, sir.
But there is common base. Like in science, we have some calculations. Okay. Like there can be other parameters that are also applied to other fields. Okay. The base remains same. Okay. So what I'm telling here, please understand, we have to make the precaution. Okay. We have to make the precaution. We have to take the extra care where there can be chances of error. Like I tell here, generally what we do in theory, we just say heat carried by gas is heat supplied by heater. Like here, gas is moving, here we are giving heat. But what happens outside? There is heat loss. Okay. So that loss we have to also take into account to improve our accuracy of the research. Okay. So this can be applicable to all the fields. Okay. So we have to be very, very careful. Clear? Now we'll see what approaches are there. There are three research approaches. One is analytical. Analytical means we derive something mathematically. Okay. So what we do, we use differential equation. We then go for integration like this, and we derive. That is called as analytical. Okay. So when we go for analytical approach, what we need is very excellent mathematical skill. We need very excellent knowledge of mathematics. Okay. To become analytical is not very easy. Then comes experimental. In the experimental approach, what we do is we perform the experiment. Okay. Please understand, as I mentioned, research is empirical, means real life experience. So experimental will be a thing which can very easily believe. Okay. So if you do experimental work, there are more chances of publication of paper. But if you do some numerical, there are less chances. Okay. People believe experimental result. people believe experimental result. Okay. So it is very hectic. Experimental work is hectic, costly, takes long time to build. Okay. We sometimes we needs craftsmanship, knowledge in building the experimental setup. It is hectic. Okay. If you tell about mechanical and civil engineering, they are little hectic. Okay. But please understand, experimental people, what believes the experimental data because it is directly empirical data. Okay. Then comes simulation, numerical simulation, and like in my case, it is a computational fluid dynamics. Here, what we do, we find some governing equation, differential equation, and then we solve that equation, and then we obtain some result. Okay. So here there is a flexibility because you only do in the simulation, so no need to build that, no need to conduct the experiment, no need to search the different instruments. Okay, everything we do in the computer. Okay, so it is little bit we can say comfortable. Okay, but what happens if you go for publishing such data? It is not easy to get published. Okay, because they also know that it is a little bit easy work and it is not directly empirical. Okay, it is not directly empirical. Okay, so we can do many simulations, and sometimes what happens, the simulation which we cannot do directly, like if I want to do the simulation on Boeing aircraft, it's not possible. It is possible but very difficult. It will need very big wing tunnel that I am not having in India. You want to do the safety analysis of ship, not possible because it will require very big tunnel. Okay, so that I can do very easily in the computer. Okay, so one more time, we'll take a break for 8 minutes and join back. So just we saw research approaches possible. Okay. So we'll meet again.